Hello geographers, and welcome to this video, which is a run through the landforms of Meanders and Oxbow lakes as part of your rivers section of the physical landscapes of the UK topic. What we're going to be doing today is looking through the characteristics of a meander, so understanding what they look like as we slice them down a middle to create a cross section. We're also going to be thinking about the role of erosion and deposition and how that actually causes a meander to migrate and move around and change shape. And then what we're also going to do is think about how that can often result in the end product of an oxbow lake, which is a different type of landform, but it is effectively the end product of a meander moving. So the first thing I want us to start having a look at today is a meander. And here we have got a pretty textbook perfect example of one. So I've pointed to 4 different parts of this image with my yellowy orange arrows. And what I would like you to do is just take a bit of time to think about what you think I might be pointing at. We've got 2 of them pointing at the water and 2 of them pointing at the banks of the river. You can pause this video now to have a little bit of thinking time, and then once you've done that, come back to me and we'll discuss it together. Okay, so let's have a look first of all at the parts of the image that I've pointed to that are not water. On the right hand side, you can see that the riverbank is very different to the left. On the left, we have a cliff-like riverbank, and actually this is referred to as a river cliff. You can see that it's very similar to the cliffs you might expect on a coast, albeit here on a much smaller scale. On the right-hand side, however, we've got something that, if we were to compare to a coastal feature, looks a little bit more like a beach. And this is an area of the meander referred to as the slip-off slope. So very much a collection of sand and shingle, just as we would find on a coastal beach. Now, looking at the meander itself and looking at the water, we can hopefully start to identify that there are differences in how the water is moving across this image. On the left-hand side, you can hopefully see that the water looks a bit more turbulent. The top of the water isn't smooth. And what that's reflecting is it's reflecting a fast flow of water. So on that left-hand side next to the river cliff, we have got fast-flowing water. On the right-hand side, look how calm that is. Now that's an area of the meander that is much, much smoother and slower, and as a result of that you can probably start to work out why we have got a sequence or an area of deposition on the right hand side, which we are calling that slip-off slope. Thinking about that then in terms of differences in energy of the river from left to right or outside bend to inside bend, that's going to play quite a big part in how this meander moves and changes. So on the left hand side, you can see that there has been erosion. Can you see how we've got green sections that are obviously grass that look to have recently fallen in to the river itself? Now, what that's suggesting is that there is erosion, and we know that this is now an area of fast-flowing water. There are lots of reasons why this is a faster flowing part of the meander, but the 2 most simple reasons or explanations for it is that, first of all, that water has actually got further to go to be able to kind of get round this bend, so it is going faster as a result. Another thing to note is that this part of the river, if you can work this out, is slightly darker, which suggests it is deeper. So because it is deeper, less of the water is in contact with the riverbed, and therefore there is less friction, so it's able to move faster. And that's creating high energy water, which is leading to erosion of that river cliff. On the right-hand side, as a contrast, that calm water is quite shallow. Can you see how it's quite light, and it almost looks like you could quite easily walk into that and not find yourself getting wet beyond the knees for very long as you walk in. And what that's showing you is that this area, because it's shallow, because it's quite calm, is not going to be very high energy, and that's going to mean that we are going to end up with quite a lot of deposition, because any sediment that's held within the water as it goes over into that side of the river is going to be dropped as that water loses energy. So let's put our discussion so far onto paper. You'll find in your workbook that you have got this diagram. And before you do this task, I would recommend that you pause this video and you watch video link number 1 in the description box. I've just found a bit of footage, just a very short video of what I can only imagine is a very keen geographer or a geography teacher who has taken it upon himself to show geographers of YouTube what a meander looks like in the flesh. So sometimes these diagrams don't really do enough to show you the real world. So I definitely pause this now, go and watch that. He'll show you the different parts of the river and the different sections and sides of the meander. And then when you've done that, come back to me and we'll start thinking about labelling your diagram. Okay, so we're going to give labelling a go now, and we've mentioned most of this together, but hopefully that video just helped you put it into a real life example. So you're now going to pause this video whilst you've got these statements in front of you, and you're going to try and put them in the correct part of the diagram. Don't worry too much if you find that you're kind of struggling to work out where to put something if it looks like 2 of these boxes are pointing at the same thing. So for example, the 2 closest to the X on the left hand side, which is obviously the slip off slope here, there could be 2 statements that you could have going in either of those 2 boxes. Because it's pointing to the same thing, it doesn't matter. You could say the same thing about the 2 boxes in the bottom right hand side. They're pretty much pointing to the same thing. As long as you are effectively pointing to the right area, inside versus outside bend, you can't really go wrong here. Give it a go, and once you have exhausted your own efforts, then come back to me and we will go through some of those answers together. Okay, so let's have a look at the ones that you should have written in the area where we've got this X and obviously all of those little bits of material. So obviously this is called the slip-off slope, and it's created of sand and shingle deposited on the inside of the river. And then what you should also have on that side is the slower current. Remember, we spoke about how this area is shallower and therefore more of the water is in contact with the riverbed. There'll be more friction and that will slow it down. Let's have a look at the other side. So this is the outside bend. Why is the outside bend in this diagram? And you can always tell by just looking for the deepest part. So here you can see that that cliff is being undercut, just like the waves do to a coastal cliff. The river will be doing the same thing. So it's effectively creating what we would call in coasts a bit of a wave cut notch. Here we can't call it a wave cut notch. It will just be undercutting by the river. And remember that as we are in the middle and lower course here, there's going to be a lot more lateral erosion because the river is going to be flung from side to side as it goes around the meanders. So there'll be a lot of lateral erosion, which is why you get the erosion of the sides more than you get erosion of the base and the river bed itself. So as we said, because this is quite strong kind of water flow, you're likely to have the possibility of things being lifted up in the water because it's quite strong. And therefore things like sands and silts can be picked up by the river at this point and held in suspension. And then those final 2 are hopefully pretty self-explanatory. We've got the river cliff at the top and the fastest current obviously pointing to the very deepest part and the outside bend of that meander. Okay, so what we're going to use now is the knowledge that we've got of erosion and deposition and which happens on each side of a river meander to think about how river meanders migrate, so move across a floodplain. So this picture is not always going to look like this, and actually this can happen pretty quickly in certain parts of the world where we get meanders shifting and moving around on a floodplain quite quickly. There are some brilliant kind of time-lapse satellite photography videos on YouTube if you wanted to have a look at that in action. But what we're going to do is just predict how this meander is likely to change in the future. And to do that, we really need to look at where the outside bends are, because that will be the direction of change. The meander will move in the direction of the outside bend because, of course, that's where the erosion is going to be happening. So let's start at the bottom. We have got here the outside bend on this side. Quite a misleading one to start with, actually, because there does seem to be some sediment there alongside that river cliff. But I think this photograph is just a river in quite low flow. So it's just that maybe the bottom of the river has been exposed. So we can work out though still, just because of the shape of the river itself, that that's the outside bend. And what that means is that where this first star is, this river will end up moving to the right, because as it erodes in that direction, the slip-off slope on the other side, the inside bend, is going to effectively catch up. So it's going to basically follow that outside bend as it moves to the right. Now the opposite is going to happen on the next bend, because the outside bend on this side is the left-hand side one. And then we've got a lovely textbook perfect slip-off slope on the other side where we've got deposition. So this meander is going to move to the left here. So you can kind of imagine it's kind of going to become much more exaggerated here. There's going to be a much bigger zigzag effect. Now, obviously, if we carry on towards the back of this, we can see that, again, this part, this outside bend, is going to move to the right-hand side, and then the slip-off slope on the other side will follow it. So the meander will move to the right here. The one I'm interested in terms of this picture in, though, is this one. So if you have a little look, this outside bend here is quite close to a river, a section of the river that's quite straight, which is closer to the kind of bottom of this picture here. So what's going to happen is this area highlighted by this star is going to erode, and it's going to erode and erode and erode until eventually it's going to get very close to this bank here. Remembering, obviously, deposition will happen on the inside bend, which will cause it to move up along with it. So this area here could potentially see these two bits of the river, so the bit with the star and the bit closest to the foreground, to the bottom of this picture, connecting. And what that's going to create on the right hand side here is it's going to create an Oxbow lake. So this is what an Oxbow lake looks like once it's formed, and eventually this will actually lose all of its water because it's not connected to the river, and it will become what we know or call an meander scar. But we're going to look at the process that's led to this happening. So kind of from this picture to this. Obviously it's two different rivers, but the process is the same. So I found a really nice little run through that's actually led by another geography teacher on YouTube. And this one is particularly good because she has what looks like a paint function where she draws this diagram and explains how meanders are created, how they lead to the creation of Oxbow lakes. So I'd like you to now pause this and watch this 4 to 5 minute tutorial on how meanders will become an Oxbow lake. And then you're going to come back to me, start this video up again, and we're going to work towards getting an explanation around the 4 images that you have got in your workbook. Okay, so before we start, there are some key terms that I'd really like most of you to try and use as we start to explain this process. So you'll have heard Mrs. Geography, as if that is her last name. I don't think so, but it's a pretty good YouTube name, I think, mentioned something called a thalweg. So the thalweg is basically just the fastest flowing part of a river. So here, for example, it's the purple line with the arrows on it. Can you see where the A's are? That's showing you the cross section across a straight bit of a river. So the fastest flowing water in the straight bits of the river is going to be right in the middle, because that tends to be where it's deepest. If you have a look at B though, of course, we know that the cross section of a meander is very different. You're going to have the deeper side on the outside bend, and that's going to be where the fastest flow is. So notice how that purple line comes closer to the outside bend as it goes around that corner. Now, the other key term that I really want you to try and use within your explanations in a second is this key term called the helicoidal flow. So there's lots of science behind why this happens, but as a GCSE geography student, you just need to know that it does happen and therefore the impact that has upon the river. So as water moves around a meander, it actually doesn't go in a perfectly straight line. It kind of corkscrews in a spiral effect. And what that does to the river is it basically scoops up sediment as it is eroded from the river cliff and then dumped on the other side as it kind of corkscrews back round and is dropped onto that slip-off slope. So the reason we talk about it as geographers is it actually speeds up the process of deposition because it takes sediment from one side, from the outside bend, and then drops onto the slip-off slope and therefore creates a bigger kind of beach of sediment. Okay, so I'm going to give you two options here in terms of how you do this next task. I think that a lot of you will be able to explain what's going on in each of these 4 pictures. Obviously on the screen at the moment you can only see 1, but the other 3 are also there within your booklet. So I'd like you to try and challenge yourself, if you can, to explain what is happening in each of these pictures without any support from me. That would be the big challenge bit. Okay, but if you feel that you need a little bit more support, what I'm also going to do after this is I am going to give you a bit of a fill in the gaps structure. So if you would rather work through the fill in the gaps structure, then that's absolutely fine. But do make sure that you would be able to do this in some way by yourself, because of course, this sort of explanation that we're just about to run through would be typical of the expectation of a 6-mark question in the paper of physical landscapes of the UK. So if you're going to give this a go solo, then well done you. You can pause this video now, and then once you're done, you can just follow through my fill in the gaps bit afterwards. So just check that you've got everything that you need. If you are wanting to do the fill in the gaps option, then you are not going to pause now. You are just going to continue for a few more moments and then hopefully kind of start working through that fill in the gaps activity instead. Okay, so here are your first couple of sentences that you need to write next to picture A, and the words that you need are here. So this is the point at which you are going to pause, fill in those gaps, and then come back to me to check your answers. Okay, so answers are as follows. The river moves from side to side when it avoids rocks on the riverbed. That's why we get that meander in the first place. It's water trying to get around something. The water flows faster on the outside bend because it has further to travel. Let's have a look at that second picture. Can you see how much that meander has become much more exaggerated because of that erosion on one side and deposition on the other? Here are your sentences. Pause now looking at those missing words, fill them in, and then let me know by unpausing that you're ready to go through those answers. Okay, so off we go. Erosion on the outside produces a river cliff. The inside is slower and the river deposits material here, such as sand and shingle. The helicoidal flow moves material from the river cliff to the slip-off slope. Okay, we're not quite yet at Oxbow Lakes, are we? But we're not too far off. Here is the third picture. Can you see how much more extreme that bend in the river has become? And we've now got 2 outside bends, which is the orange colour, starting to almost meet in that centre part that's referred to as the meander neck. Here are your sentences to work through, and here are your missing words. Unpause when you are ready. Okay, so answers are: the river has continued to erode and it has made the meander bigger. The narrow end of the meander has become close, forming a meander neck. I don't like that it's called a meander neck because ultimately we all know what's going to happen in the next picture, don't we? That neck is not going to stay as it is. But that is the official geographical term for it. Okay, here we go. Last one. Here are your sentences. Here are your words. Pause now and then unpause once you're ready to check. Okay, so a flood has occurred. So it's worth noting, by the way, before I continue, that a flood is absolutely necessary for that final breakthrough of that neck to get this part of the river moving in a straight direction away from that old meander, which has obviously become an Oxbow Lake. So a flood has occurred and the river has taken the shortest route across the neck, cutting the meander off and forming an Oxbow Lake. So although I'm perfectly aware that rivers are not living things as such, we can kind of think of them as quite lazy. What they want to do all the time is get to the mouth as quick as they possibly can. And there's a couple of reasons for that. One of them is gravity, and the other one is that they've got this big push of water behind them. So the kind of mass of water behind them is creating an extra push. So all of that kind of is more efficient if it's kind of moving directly downhill. So as soon as this is created, there's going to be no interest in this river in kind of moving around that old meander, because it's just a waste of time, and actually gravity is not on its side if it wants to do that. So what will obviously happen, like I said, is that lake, that kind of Oxbow or kind of horseshoe shaped lake, will eventually dry up to the point where it's not a lake anymore and become a meander scar. So what we're going to do is I'm just going to give you a final activity today to check that you have understood everything that we've spoken about in this video. So you're going to find somewhere to write 1 to 10 down the margin. It can either be in the rough notes in the back of your booklet if that's how you're working, or it can just be on a bit of paper. And then you're just going to write T or F to identify whether you think these statements are true or false. So here are your statements. I'm going to ask you to pause this video for a final time, and then once you think you have worked out whether these are true or false, you're going to unpause the video so that I can just check those answers with you. Okay, number 1 then, the outside of the river bend is deeper. That is of course true. We know that, and that is one of the reasons why it is fast as well. Number 2, the inside of the bend is faster. We know that is false, because on the inside bend of a meander, it is going to be causing deposition. We've got another true. The inside of the bend is the slip-off slope. So because of that deposition, we are getting this river beach, which you mustn't call it, by the way. It's not called a river beach, but it helps you envisage what I'm talking about. This beach of sediment on the inside bend that we need to refer to as the slip-off slope. The outside of the bend is the river cliff. Of course, that's true because it's fast flowing water. We get lots of erosion. Number 5 is false. The inside of the bend is not where we get erosion. As we said, we get deposition there. The outside bend is where we get suspension. That is true. Because the sediment is able to be lifted up by high flow water, then that is going to obviously be a possibility on the outside bend. Another true, the inside bend of the meander is where stones and pebbles will be laid on the slip-off slope. Number 8 is false. The inside of the bend is where we get undercutting. Undercutting needs erosion, and we know that the inside bend is deposition based, so we're going to need that undercutting to be on the outside bend. So that one's false. Meanders are formed by vertical erosion. So if you remember from your first lesson on rivers, vertical erosion actually occurs in the upper course because it's very high up, or definitely the highest up part of a river. And that's going to mean there's lots of gravitational potential energy pulling down on the water. So you get lots of erosion of the bottom of the river. Here, though, of course, because we're kind of moving from one side of the floodplain to another and water is being thrown around corners, it will be lateral erosion. So the sides of the river will erode. So vertical erosion is not associated with meanders. Lateral erosion should be the statement that you would put there if that was true. And the last one, Oxbow lakes are formed when the river's energy is high. We need a big flood or some sort of huge kind of increase in water to finally break through that meander neck to create this new straighter channel of the river in place of what was a very extreme meander. Okay, so here marks the end of our lesson. So just a reminder of what we've managed to do in this video. You've hopefully got a good understanding of what the characteristics of a meander are as we slice through it and look at its cross-section. We've thought about how meanders will move across the floodplain through the process of erosion happening on one side and deposition on the other. And we've thought about the very final element of that process of moving around the floodplain, where if you get two outside bends joining together, then you will get the formation of that second landform being the Oxbow Lake. So I hope that was all nice and clear for you. Don't forget that there was a good amount of answers given within that as well. So if you do need to go back and check any of those and you forgot to pause to improve and complete your notes, then please go and do that. Otherwise, we can finish here. So well done for completing this lesson. Do let your teachers know if they can help you in any way, and thank you for watching.